All right, so now let's talk about some mixed practice with solving logarithmic equations. So again, I got to check, do I have logs on one side or both sides? Here I only have on one side, so I'm going to use our definition. My argument is c plus 11. My base here is 3. My power is going to be 4. If I take 3 to the 4th power, that's going to be 81. And then I'm going to subtract 11 from both sides. That's going to give me c equals 70. So let's plug in 70. 70 plus 11 is 81. Log base 3 of 81. Well, 81 is 3 to the 4th power, so that will give me 4. So it does check. So for the next one, I've got logs on both sides. So we're happy with that. So that means I don't have to really worry about the base here. I'm just going to be writing as a single log and then setting the arguments equal to each other. So this will be log base 5. We have subtraction, so this is going to be a quotient. So that's going to give us log base 5 of 3x plus 2 over x equals log base 5 of 4. All right, so we're going to set the arguments equal to each other since log is a one-to-one function. My LCD here is going to be x, so I'm going to multiply both sides by x. And just kind of noting here, x cannot be equal to 0. So that gives us 3x plus 2 equals 4x. Well, I'm going to take away 3x from both sides. So 2 equals x. So let's check it. 2 times 3 is 6 plus 2 is 8. That's 2. Both of those check. 8 divided by 2 is 4. So that gives us log base 5 of 4. So it does check. So 2 would be my answer. Okay, so this one, okay, so again, we've got to read the directions carefully. Write the solution with the exact solutions. Also give the approximate solutions to 4 decimal places if necessary. Should be a comma there. So logs on both sides. So I'm going to set the x squared minus 3x equals to 28. We're going to subtract 28 from both sides. And I want to find factors of negative 28 that add up to 3. So we want to do 4 and 7 with the 7 being negative. So it'd be x plus 4 times x minus 7 equals 0. Set each factor equal to 0 and solve. This will give us x equals negative 4, and this will give us x equals positive 7. Now I need to check both of these, so I'm going to first check the negative 4, and let's do it on a calculator. So I'm going to do parentheses negative 4 squared minus 3 parentheses negative 4. That's 28, so that checks. So let's check the 7. Both of them check. Both of them are going to give us log of 28, and that's what we want. So here, both the answers work. Let's try number 10. So we have a sum, so we're going to rewrite that as a log of a product. And let's FOIL this out. So that's log base 2. That'll be n squared plus 3n minus 4n to negative n. Negative 4 times 3 is negative 12. Since we only have logs on one side, so we need to rewrite this as an exponential. So my argument is n squared minus n minus 12. My base here is 2. My power here is 3. 2 to the third is going to be 8, so it's going to be n squared minus n minus 12 equals 8. We want to take away 8 from both sides, so that'd be n squared minus n minus 20 equals 0. And then I want to look for factors of negative 20 that add up to a negative 1. So we're going to do 4 and negative 5. So the n plus 4, n minus 5 equal to 0. So the n plus 4 equals 0 is going to give us n equals a negative 4. The n minus 5 equals 0 is going to give us n equals 5. Now I've got to check both of these. Let's start with the negative 4. Well, I'm going to run into trouble right here. So I plug in a negative 4. That's going to end up, just for that first term, is going to give me log base 2 of negative 8. And that means we're in big dog do. So that's undefined. Sorry about the smell. So we're going to have to reject the negative 4. All right, let's try the 5. 5 minus 4 is 1. Log base 2 of 1 is 0. Okay, that's fine. 5 plus 3 is 8. Log base 2 of 8 is 3. So the 5 actually checks. So our answer here is going to be 5. So let's turn the page. And let's do some applications. So we've been doing all this solving, and now we're ready for some applications. So in 2020, the population estimate was approximately 32 million with a 0.69% annual growth rate. At this rate, the population P/T in millions can be approximated by P of t equals 332 e to the 0.0069 t, where t is the time in years since 2020. What will be the population in 2050? So that's going to correspond to t equals 30 years, because it's from 2020 to 2050. And we're just trying to find the population. So all we're doing, we're not even solving here, we're just evaluating this at 30. So we're just going to pop that into our calculator. Excuse me. And what they say round off here? I guess we'll go and round off to nearest millions. So it'd be about 408 million. All right, let's try another example. In the formula, P of t equals P sub 0 e to the RT, P of t is the population as small as many after time t in years. P sub 0 is the initial population, R is the growth constant. A certain city currently has a population of 41,000 people, and the population is increasing at 2.4% per year. How many years will it take for the population to reach 70,000 people? Round to the nearest year. So, let's figure out what we have. This 41,000 people, that is our P sub 0. We have the growth rate, 2.4%, which we need to write that as a decimal. So that'd be 0.024. We don't know what the time is. That's what we're trying to find. We're trying to figure out how long is it going to take to reach 70,000 people. So we're trying to solve for t. So let's grab our calculator. And we're going to first divide both sides by 41,000. No, that's 70 over 41. We'll just leave it as a fraction. So I'm trying to get at t. T is an exponent. The only way I can get it as an exponent is I'm going to have to change this to a log equation. Fortunately, my base is e, so that's going to be natural log. So that's my exponent, 0.024t equals natural log of 70 over 41. Okay, so now let's take the natural log. I'll go ahead and grab that answer of 70 over 41. All right, so that's 0.024t is 0.53 blah blah blah. Now to solve for t, I'm going to need to divide both sides by 0.024. So I'm going to take that answer, divide it by 0.024. So it's a little over 22 years. Okay, let's go ahead and turn the page. And let's take a look at number 13. The intensity I of an earthquake is measured in a seismic graph, a device that measures amplitudes of shock waves. I sub 0 is a minimum reference intensity of zero-level earthquake against which intensities of other earthquakes may be compared. The magnitude m of an earthquake of intensity I is given by m equals log of I over I sub 0. In 1980, the Loma Prieta earthquake with a magnitude 6.9 damaged the city of San Francisco. A few years later, there was another earthquake with a magnitude of 3.4 near San Francisco. What was the intensity of the earthquake in 1989? Okay, so we're going to set m equal to 6.9. And I'm trying to find out what the intensity is. So I'm trying to solve this in terms of I. So I'm going to rewrite this as an exponential equation. My base here is 10. So this would be 10 to 6.9 equals I over I sub 0. So let's take 10 raised to the 6.9. Pretty awful looking number. And then we're going to multiply that by I sub 0. So this is 7943282. Let's just round it to the whole number there. Equals I over I sub 0. And then we're going to multiply both sides by I sub 0. So we can see that the intensity of that earthquake in 1989 is almost 8 million times the minimum intensity. So that's a pretty bad earthquake. Now, let's do the same thing for part B for the second earthquake. So we're going to have 3.4 equals log I over I sub 0. So we go ahead and rewrite that in exponential form. I'm going to take 10, caret key 3.4, and let's just call it 2,512. And then multiply both sides by I sub 0. So that earthquake was a little over 2,500 times the minimum intensity. So notice as we move on the Richter scale, this is not double the intensity. Look how much more intense that is. In fact, that's what they ask us in part C, is to find out how much stronger the earthquake in 1989 was compared to the second earthquake. So to find that out, I would actually divide that. And I tell you what, let's get a little more accurate answer. Let's use the numbers we have from our calculator. So I'm going to do my fraction key. I'll go ahead and grab that first number. And then go ahead and grab that second. Nope, didn't put in the right spot. Crap. All right, let me think how we're going to. All right, no, we're going to do this. Our fraction key. I'm going to grab the first number. Arrow down, and I'm going to do my second key and my negative sign here to put the last answer, which would be the second number. Hit enter. So you can see it's over 3,162 times stronger. What that means is that when you're talking about something on the Richter scale, something going, a magnitude of 7 versus a magnitude of 6, its power is above 10. So a magnitude 7 earthquake is 10 times stronger than a magnitude 6 earthquake. Let's try this next example. Actually, let me stop here. This video is getting a little bit long. We'll pick this up in the next video.